Hello students, welcome to MGC Learning. I am Manju Dilip. Today I am going to start with the 12th standard mathematics topic, probability distribution part 5. So in the previous video we have studied about probability density function. So today we are going to solve some more questions related to probability density function. So the first question, let x be the amount of time for which a book is taken out of library by a randomly selected student, and suppose that x has PDF f of x is equal to 0.5x for 0 less than or equal to x less than or equal to 2 and 0 otherwise. Calculate probability of x less than or equal to 1. So here the given function f of x is equal to 0.5x for 0 less than or equal to x less than or equal to 2. We have to find probability of x less than or equal to 1. So consider that function. Here the lower limit is not given, so we can take the lower limit as 0 and upper limit is given as 1. So integral 0 to 1 f of x dx is equal to integral 0 to 1 0.5x dx is equal to 0.5 integral of x dx is x square upon 2 from 0 to 1, that's equal to 0.5 upon 2, 1 square minus 0 square, upper limit square minus lower limit square, that's equal to 0.5 upon 2. This can be written as 5 upon 20, that's equal to 1 upon 4. Second question, probability of 0.5 less than or equal to x less than or equal to 1.5. So we have to find the probability of this one. Here the lower limit is 0.5 and upper limit is 1.5. So integral 0 to 5, 0.5 to 1.5 into f of x dx. Here f of x dx is 0.5 x dx. So 0.5 into x square upon 2 from 0.5 to 1.5. That's equal to 0.5 upon 2 into 1.5 whole square minus 0.5 whole square, that's equal to 5 upon 20 into 2 minus 2.25 minus 0.25, that's equal to 1 upon 4 into 2, that's equal to 1 upon 2. That's the answer for the second question. Now the third question is probability of x greater than or equal to 1.5. So probability of x greater than or equal to 1.5 is here the only lower limit is given, upper limit is not given. So we can take this upper limit as 2 from the question. So integral 1.5 to 2 0.5 x dx is equal to 0.5 into x square upon 2 from 1.5 to 2, that's equal to 0.5 upon 2, 2 square minus 1.5 whole square, that's equal to 1 upon 4 into 4 minus 2.25, that's equal to 1.75 upon 4, 175 upon 400, that's equal to 35 upon 80 is equal to 7 upon 16 is the answer for the third question. Next question is, suppose error involved in making a certain measurement in a continuous random variable x with PDF f of x is equal to k into 4 minus x square 4 minus 2 less than or equal to x less than or equal to 2 and 0 otherwise. Calculate probability of x greater than 0 and probability of minus 1 less than x less than 1. Since f of x is a probability density function, integral minus 2 to 2 f of x dx is equal to 1. So integral minus 2 to 2 k into 4 minus x square dx is equal to 1. So k into 4x minus x cube upon 3 from minus 2 to 2 equal to 1. Applying the upper and lower limits, you will get k into 4 into 2 minus 2 cube upon 3 minus 4 into minus 2 minus 2 whole cube upon 3, that's equal to 1. So k into 8 minus 8 upon 3 minus 8 minus 8 upon 3 is equal to 1. So k into 24 minus 8 upon 3 minus 8 plus 8 upon 3 is equal to 1. So k into 16 upon 3 minus 24 plus 8 upon 3 equal to 1. So k into 16 upon 3 minus 16 upon 3, that's equal to 1. So 32k is equal to 1. So k is equal to 3 upon 32. Therefore the function will become, in the place of k we can substitute this value. So 3 upon 32, 4 into 4 minus x square, 4 minus 2 less than equal to x less than equal to 2. Now you have to find probability of x greater than 0. So integral 0 to 2, 3 upon 32, 4 minus x square dx, that's equal to 3 upon 32, 4x minus x cube upon 3 from 0 to 2, giving upper and lower limit, you will get 3 upon 32 into 24 minus 8 upon 3, that's equal to 1 upon 2. is the answer for this question. Next question is probability of minus 1 less than x less than 1. Here lower and upper limit is given as minus 1 and 1. So we're giving that minus 1 to 1, 3 upon 32 into 4 minus x squared dx. So 3 upon 32, 4x minus x cube upon 3, from minus 1 to 1, 3 upon 32, 4 minus 1 upon 3 minus minus 4 minus minus 1 upon 3. 3 upon 32, 12 minus 1, that is 11 upon 3, minus minus 4 plus 1 upon 3, that is minus 3 upon 3. So you will get 3 upon 32, 14 upon 3, that's equal to 14 upon 32 can be written as 7 upon 16 is the answer for this question. Next question is, the following is the PDF of a continuous random variable f of x is equal to x upon 8, where 0 less than x less than 4 and 0 otherwise. Find the expression for CDF of x. Also find its value at x is equal to 0 0.5, 1.7 and 5. So cumulative distribution function of a continuous random variable x is given by capital F of x is equal to integral minus infinity to x f of y dy. So given function in this example, range of x starts at 0 because here the lower limit is 0. So capital F of x is equal to integral 0 to x f of y dy is equal to integral 0 to x y upon 8 dy. So y square upon 16 from 0 to x. So x square upon 16. So capital F of x is equal to x square upon 16. The second question is, find its value at x equal to 0 0.5, 1.7 and 5. So values of f of x at different values of x are found by substituting given value of x in the expression obtained above. So here capital F of x is x square upon 16. So at x is equal to 0 0.5, f of x is equal to f of 0 0.5, that's equal to 0 0.5 whole square upon 16, that is 0 0.25 upon 16, that's equal to 1 upon 64. Similarly 1.7 also you can substitute here. So f of 1.7 is 1.7 whole square upon 16, that is 2.89 upon 16 is equal to 0 0.18. Similarly you can find f of 5 also. For any value of x greater than or equal to 4, here it is 0 less than x less than 4 is given. So the value which is below the value is below 0.0, and in the function which is in between 0 and 4 is x upon 8, and other values we will get capital F of x is equal to, total probability will be 1. So f of y is equal to 1. That's the answer for this question. So next question is, the probability density function of a continuous random variable x is given by f of x is equal to 1 upon 2a, 0 less than x less than 2a, where a greater than 0 and 0 otherwise. Show that probability of x less than a upon 2 is equal to probability of x greater than 3a upon 2. We have to show this part. It's a probability density function is given, and probability of x less than a upon 2 can be written as integral 0 to a upon 2 1 upon 2a dx. Solving this one, 1 upon 2 into x from 0 to a upon 2. So applying upper and lower limit, you will get a upon 2 upon 2a. So a cancelled, 1 upon 4 is the answer for that. And probability of x greater than 3a upon 2 is integral 3a upon 2 to 2a, 1 upon 2a dx. 1 upon 2 is a constant, we can take it out. And integral of 1 dx is x from 3a upon 2 to 2a. So 1 upon 2a, 2a minus 3a upon 2. So 1 upon 2a into 4a minus 3a upon, that is a upon 2, that's equal to 1 upon 4. So probability of x less than a upon 2 is equal to probability of x greater than 3a upon 2. Now we got both the values separately. We found this one, and we have showed this value is equal to probability of x greater than 3a upon 2. Now if a random variable x has a probability density function f of x is equal to c upon x for 1 less than x less than 3 and 0 otherwise, where c greater than 0 is also given, find c. So f of x is equal to c upon x for 1 less than x less than 3. Since f of x is a probability density function, integral 1 to 3 f of x dx is equal to 1. Integral 1 to 3 c upon x dx is equal to 1. C into integral 1 to 3 into 1 upon x dx is equal to 1. So c into log x from 1 to 3 is equal to 1. C into log 3 minus log 1 equal to 1. So c is equal to 1 upon log 3 minus log 1. Since log 1 value is 0, 1 upon log 3 is the value of c. Some exercise questions are given to you, you have to solve it. Thank you.